Have you ever felt that intense frustration when your video buffers at the crucial moment, or your game freezes just as you're about to make the winning move? It's not just annoying, it can actually cost businesses millions and derail critical operations. We often blame our Wi-Fi or our internet provider, believing that faster speeds are always the answer. But what if the real problem isn't how fast your data travels, but how far it has to go? Imagine this: every single time you click a button, stream a movie, or ask a smart assistant a question, your data often has to travel hundreds, even thousands, of miles to a massive data center. It's like sending a postcard from New York to California just to say hello to your neighbor next door. All that distance adds up, creating something we call latency, the tiny, often imperceptible, delay that can make or break your online experience. If we don't understand this fundamental challenge, we're building the future of the internet on a slow, shaky foundation, and our increasingly connected world will simply grind to a halt. What we need to understand is that the traditional model, where all computing power is centralized in giant data centers far away, is becoming a bottleneck. As more and more devices connect to the internet, from our smartwatches to autonomous cars, the sheer volume of data, and the immediacy required for processing it, demands a new approach. This isn't just about faster downloads, it's about making our digital world truly instantaneous and responsive, enabling innovations that were once impossible. Let's break down how this invisible secret is actually making your internet feel lightning fast, and how it's shaping the future of technology right before our eyes. Now, let's picture how our digital world usually works. For years, the cloud has been our digital powerhouse. Think of it like a giant, super-efficient factory located hundreds of miles away. All your requests, all your data, every single piece of information has to travel to this central factory, get processed, and then travel all the way back to you. It's incredibly powerful, no doubt, but that long-distance round trip introduces delays, those pesky milliseconds we talked about. This is the internet's current data highway, many lanes, but all converging on a single, distant destination. The problem starts becoming glaringly obvious when we consider the sheer volume of data being generated today. Every second, billions of devices, from your phone to industrial sensors, are spitting out data. Imagine every car on a busy highway suddenly deciding to send a letter to the same post office, hundreds of miles away, at the exact same time. The postal service would be overwhelmed, and your letter would take ages to arrive. This centralized model, while revolutionary for its time, is simply not equipped to handle the instantaneous demands of modern applications. We're facing a massive data traffic jam, where critical information needs to travel further than ever before, but also arrive faster than ever before. This isn't just an inconvenience for streaming a movie, it's a critical limitation for technologies that rely on real-time decisions. Think about an autonomous car navigating city streets. If it has to send data to a distant cloud to decide whether to brake or swerve, even a fraction of a second of delay can have catastrophic consequences. We need our data to be processed not just fast, but right where the action is happening. This fundamental shift in thinking is what brings us to the core of edge computing, moving the processing power closer to you, closer to the devices, and closer to the very edge of the network. It's like building mini factories or local postal offices right in your neighborhood, drastically cutting down on travel time. And here's where it gets interesting: edge computing. If the traditional cloud is a massive central library in a distant city, edge computing is like having mini libraries or local branches right in your neighborhood. Instead of sending every single book request or every piece of information all the way to the main branch, you go to your local branch. Most of what you need is right there, and for anything super specialized, it can still pull from the main library, but the immediate needs are met locally. That's the core idea. What we're doing with edge computing is strategically placing smaller data centers, or edge nodes, physically closer to where the data is actually generated and consumed. These aren't full-blown cloud data centers, they're more like powerful, localized outposts, packed with computing power, storage, and networking capabilities. They act as a local hub, processing immediate data requests right there, reducing the need for everything to make the long, arduous journey to a central cloud. This dramatically cuts down on the travel time for your data, making applications incredibly more responsive and efficient. Think of a smart city filled with thousands of sensors monitoring traffic, air quality, and streetlights. If every single sensor had to send its data to a cloud server hundreds of miles away for processing, the network would be constantly overloaded, and decisions would be delayed. With edge computing, mini servers placed strategically around the city can process the local sensor data in real time. They can detect a traffic jam and adjust traffic lights instantly, without ever needing to consult a distant server. This not only makes the city smarter but also much more efficient in its operations. It's about decentralizing intelligence, pushing the processing power to the periphery, where it's needed most. But the genius part is this: why does this speed matter so much? We're talking about milliseconds, tiny fractions of a second that seem insignificant to the human eye. Yet, in the world of technology, these milliseconds are the difference between a seamless experience and a frustrating one, or even worse, a dangerous one. Latency isn't just about waiting for a page to load, it's a critical barrier to the next generation of technological innovation that we're all so excited about. It's the silent killer of user experience and the ultimate roadblock for real-time applications. Consider online gaming, for instance. If your command takes even 50 milliseconds longer to reach the server and come back than your opponent's, you're at a significant disadvantage. Competitive gamers demand extremely low latency, often below 20 milliseconds, because every single one of those fractions of a second directly impacts their performance and the fairness of the game. That's why you might feel that subtle lag, where your character doesn't quite respond as quickly as you expect. This isn't just about fun, it's about a smooth, equitable digital interaction. And it goes way beyond entertainment. For technologies like autonomous vehicles, where cars make split-second decisions about braking, accelerating, or swerving to avoid obstacles, latency of even a few milliseconds can be the difference between safety and disaster. Imagine a self-driving car needing to identify a sudden hazard and reacting instantly. Sending that data to a distant cloud and waiting for a response is simply not an option. The computations must happen at the edge, literally on the vehicle itself or on a nearby roadside unit, guaranteeing near-zero delay. Ever had that happen where your internet felt so slow it actually impacted something important? See the pattern here? Latency is truly the enemy when it comes to reliability and responsiveness in our increasingly automated world. Now, you might think, okay, faster internet, got it. But edge computing offers so much more than just speed. While lower latency is a huge win, it brings a suite of other powerful advantages that are often overlooked, yet are absolutely critical for modern applications. It's not just about getting data there quicker, it's about making the entire system more robust, secure, and efficient. We're essentially making our digital infrastructure smarter and more resilient by distributing its intelligence. One major benefit is enhanced security. When data is processed locally at the edge, it doesn't always need to travel across vast networks to a central cloud. This significantly reduces the points of vulnerability where sensitive information could be intercepted or exposed. Think of it like a local bank branch handling your daily transactions. Your money doesn't have to fly across the country for every single deposit or withdrawal, making those smaller, local transactions inherently more secure than if everything always went through a single, massive, distant vault. Plus, if a central cloud system ever goes down, the edge can often continue to operate independently, maintaining critical local functions. Another huge win is lower bandwidth usage. If every single smart device in your home, your doorbell camera, your thermostat, your smart speaker, constantly streamed all its raw data to the cloud, our internet pipes would quickly become saturated. Edge devices can process and filter that data locally, sending only the most crucial or summarized information back to the central cloud. This saves massive amounts of bandwidth and reduces networking costs for companies. Now, you might be thinking, doesn't this make everything more complex to manage? While initial setup can be more involved, the long-term gains in efficiency, security, and performance often far outweigh that complexity, especially for large-scale deployments. It's a strategic investment that pays off in spades, empowering us to build truly scalable and resilient digital systems. Let's get practical and look at where edge computing is already making a real-world impact. This isn't just some futuristic concept, it's happening right now, powering the innovations we see every day and enabling capabilities that were once confined to science fiction. Remember what we said about latency being the enemy of innovation? Well, this is where edge computing truly shines, providing solutions for some of our most demanding technological challenges. It's the silent workhorse behind truly intelligent systems. Consider autonomous vehicles again. We briefly touched on this, but it's a perfect example. These cars are essentially data centers on wheels, equipped with dozens of sensors, cameras, radar, lidar, generating terabytes of data every single day. If that car had to send all that raw data to the cloud to decide if it should brake or turn, the delay would be catastrophic. Instead, edge computing allows the car's onboard systems to process the data in milliseconds, identifying pedestrians, reading traffic signs, and reacting to changing road conditions instantly. This local processing is fundamental to making self-driving cars safe and reliable, literally saving lives by eliminating crucial delays. Another compelling application is in industrial settings and smart factories. Imagine a factory floor with hundreds of robotic arms and machines, all needing to coordinate their movements with extreme precision. Edge devices located on the factory floor can monitor machine performance, detect anomalies, and even predict potential failures in real time. This allows for immediate adjustments or preventative maintenance, avoiding costly downtime and ensuring smooth operation. In healthcare, edge computing enables remote surgery with incredibly low latency, allowing surgeons to operate on patients hundreds of miles away with near-instantaneous feedback. This transformative technology extends our capabilities and brings advanced care to underserved areas. What would you do here if you needed real-time precision? You'd bring the compute closer, wouldn't you? So, who's actually building this new frontier? Edge computing isn't a static concept, it's an evolving landscape driven by major tech players and a constant stream of innovation. The idea of moving computation closer to the data source has been around for a while, evolving from concepts like fog computing into the sophisticated edge platforms we see today. It's a collaborative effort across industries, all aiming to unlock the full potential of distributed intelligence. Major cloud providers like Amazon Web Services, Microsoft Azure, and Google Cloud are all heavily investing in edge solutions. They offer services that extend their cloud capabilities to local edge devices, allowing developers to deploy and manage applications that run seamlessly across both environments. For example, AWS IoT Greengrass allows you to run AWS Lambda functions, containerized applications, and machine learning inference directly on connected edge devices, making them smarter and more autonomous. This means your code can live and execute right where it's most effective, drastically reducing round-trip times and enabling true real-time processing. Beyond the big cloud providers, a host of specialized companies are emerging, focusing on everything from edge hardware to specialized software for managing distributed edge deployments. The proliferation of 5G networks is also a massive catalyst for edge computing, as 5G's ultra-low latency and high bandwidth capabilities perfectly complement the localized processing power of the edge. As we move towards a future where billions of IoT devices generate unimaginable amounts of data, and AI models need to make instantaneous decisions, the importance of edge computing will only continue to grow. Analysts predict that by 2025, 75% of enterprise-generated data will be processed at the edge, signifying a monumental shift in how we handle information. So, what have we learned? Edge computing is far more than just a buzzword. It's the invisible secret weapon making your internet faster, your devices smarter, and your future more connected. We've seen how it tackles the frustrating lag of centralized systems by bringing computing power closer to you, literally to the edge of the network. This distributed approach isn't just about speed, it's about enhanced security, reduced bandwidth demands, and improved reliability for the critical applications that shape our modern world. From empowering autonomous vehicles to make life-saving decisions in milliseconds, to enabling smart factories to operate with unprecedented precision, edge computing is fundamentally reshaping how we interact with technology. It's the underlying infrastructure that makes technologies like artificial intelligence and the Internet of Things truly viable and impactful. By understanding edge computing, we gain a crucial insight into the very foundation of our rapidly evolving digital landscape. If you found this breakdown insightful and want to dive deeper into how technology is transforming our world, make sure you're subscribed. Next up on the Emerging Tech playlist, we're going to explore another groundbreaking concept. What if you never worried about servers again? Get ready for a deep dive into serverless computing, another powerful paradigm that's changing how we build and deploy applications. Until then, keep exploring, keep questioning, and keep innovating.